Okay guys, so let's start with the steps of glycolysis. Step 1. This glucose up there will be converted to a molecule we call what? Glucose 6-phosphate. Glucose 6-phosphate. Meaning that the glucose will receive a phosphate on its seat carbon. And the question is, where does the glucose get the phosphate from? It gets the phosphate from a molecule we call ATP. So meaning that in step 1, ATP is being used, as you can see. So let's note certain things here. The step 1 that I'm talking about is an irreversible reaction. As you can see from the arrow, you can see that the arrow is coming down, only down, as compared to the other arrows which is going up and down, meaning that step 1 is irreversible. And also, step 1 requires both ATP and magnesium ion. The ATP and the magnesium ion has to come in as a complex. When only ATP comes in, the ATP will serve as an inhibitor, not an activator. Before the ATP can be an activator, it has to come with the magnesium 2+, else it will be an inhibitor. So as I said, ATP alone is what? Is a competitive what? Inhibitor for what? Step 1. ATP alone is a competitive inhibitor for what? Step 1. Note that. And this step 1 that I'm talking about is being catalyzed by a certain enzyme we call hexokinase. Hexokinase. It can also be catalyzed by an enzyme we call glucokinase. But the difference is that hexokinase is found in most of the tissues, but glucokinase is only found in the what? In the liver. So in the liver, step 1 is being catalyzed by glucokinase, but in other tissues, step 1 is being catalyzed by what? Hexokinase. Let's look at the differences here. Let's look at something here. Look at this picture. You can see that the hexokinase is present in all tissues, but the glucokinase is present in only the what? In only the liver. And you can see that this hexokinase that I'm talking about don't only work on glucose. It can work on fructose too, can work on what? Galactose too, as you can see. But the glucokinase only works on what? Glucose. It only works on what? Glucose. And another difference is that this hexokinase has high affinity for glucose. It has high affinity for glucose as compared to what? Glucokinase. Meaning that when glucose level is low in the body, it is the hexokinase that will catalyze the first step in glycolysis. But when there is more glucose in the body, glucokinase will also catalyze some of the what? Of the first step. Hope you understand. Yes, so these are some of the differences between what? Hexokinase and what? Glucokinase. So that will be all for what? Step 1. So let's move to what? Step 2. For step 2, let's see something here. For step 2, you will see that let me use this and illustrate it for you to see. In step 2, you see that the glucose 6-phosphate will be converted to what? Fructose 6-phosphate. The glucose 6-phosphate will be converted to what? Fructose 6-phosphate. Note that fructose is an isomer of glucose. So in that step, there is something going on which we call isomerization. The glucose is being isomerized into what? Fructose. And the enzyme that performed that step is called phosphoglucose isomerase. Phosphoglucose isomerase. As you can see, that is the enzyme that will catalyze the second step. And this phosphoglucose isomerase enzyme also depends on what? Magnesium 2 plus. It also depends on what? Magnesium 2 plus. So put that in mind. And the phosphoglucose isomerase enzyme is highly stereospecific. Look at something here. So the phosphoglucose isomerase enzyme is what? Highly stereospecific. Why? Is because it is converting glucose to an isomer called what? Fructose. So that enzyme is highly what? Stereospecific. Note that. Now let's move to step 3. For step 3, fructose 6-phosphate. The fructose 6-phosphate in step 3, the fructose 6-phosphate that we have will be converted to what? Fructose 1,6-bisphosphate. I don't know if you can see that. So the fructose 6-phosphate is being converted to what? The fructose 1,6-bisphosphate. And the enzyme that performs that step is called phosphofructokinase 1. Sorry for that. The enzyme is called phosphofructokinase 1. It is the enzyme that is converting the fructose 6-phosphate to what? Fructose 1,6-bisphosphate. And note that in that step 2, we are using what? ATP, as you can see. In that step 2, we are using what? ATP. Meaning that so far we've used how many what? ATPs? 2. And I said that in the preparatory phase, which is from step 1 to step 5, we will invest 2 ATP. And now we've invested 1 ATP in step 1. And now we are investing another ATP in step 3. And note that step 3 is also irreversible. You can see that it is only one arrow coming down. Only one arrow coming down. So step 3 too is what? Irreversible. Note that. Let's look at something here. I wrote something here. Let's look at that. Step 3. I said that step 3 is what? Highly spontaneous. Step 3 is what? Highly spontaneous reaction, and it is also the rate limiting step. So they can ask you in exams that what is the rate limiting step? The rate limiting step is what? Step 3. And this step 3 is being catalyzed by which enzyme? The phosphofructokinase 1 enzyme. Note that. Let's move to step 4. In step 4, what happens? In step 4, the fructose 1,6-bisphosphate will be cleaved into 2,3 carbon compounds. I've talked about this before. The fructose 1,6-bisphosphate will be cleaved into what? 2,3 carbon compounds, and they are called glyceraldehyde 3-phosphate and dihydroxyacetone phosphate. Let's look at it here. So you can see that the fructose 1,6-bisphosphate is being converted to what? These two molecules, as you can see here, these two molecules, dihydroxyacetone phosphate and glyceraldehyde 3-phosphate. That is what? Step 4. And the enzyme that is performing that reaction is called aldolase. The enzyme is called what? Aldolase. So aldolase is cleaving the fructose 1,6-bisphosphate into these two molecules called dihydroxyacetone phosphate and glyceraldehyde what? 3-phosphate. In step 5, you will see that the dihydroxyacetone phosphate will be converted to what? Glyceraldehyde 3-phosphate. The dihydroxyacetone phosphate will be converted to what? Glyceraldehyde 3-phosphate. And we will get 2 molecules of glyceraldehyde 3-phosphate in step 5, since the dihydroxyacetone phosphate will be converted back to what? Glyceraldehyde 3-phosphate. giving us 2 molecules of what? Glyceraldehyde 3-phosphate. And the enzyme that performs the fifth step is called triose phosphate isomerase. Triose phosphate isomerase. That is the enzyme that will perform the fifth reaction, triose phosphate isomerase. So put that in mind. Dihydroxyacetone phosphate is what? Is a ketone, and glyceraldehyde 3-phosphate is an aldose. Put that in mind. Dihydroxyacetone phosphate is a what? Ketone, and glyceraldehyde 3-phosphate is what? An aldose. Put that in mind. So now let's move to step 6. Step 6, which is the payoff phase. The payoff phase starts from the payoff phase starts from what? Step 6 to what? Step 10. And I say in the payoff phase, we are going to gain 4 molecules of ATP and 2 molecules of what? NADH. Put that in mind. And since in step 5 we produce 2 molecules of glyceraldehyde 3-phosphate, since in step 5 we produce 2 molecules of glyceraldehyde 3-phosphate, it means that from step 6 to step 10, all the